Since 1911, Tyler Union has been providing the highest quality fittings, joint restraints, accessories, valve boxes, and other castings to the waterworks industry. With a production range of 3-inch through 48-inch, Tyler Union is the one manufacturer capable of supplying a full line of both domestic and import products with the highest level of quality and customer service in the industry. Maintaining a safe work environment for our employees, employing green manufacturing procedures, and putting out products that set the standard for quality are the keys to our longevity. At Tyler Union, we strive to meet our customers' needs in every way possible. The following is a tour of our Union Foundry facility in Anniston, Alabama. The tour starts with receiving scrap metal, then follows the manufacturing process all the way through to the final product being put into inventory and shipped out. At the end of this tour, you will have a better understanding of both the manufacturing process and the unparalleled commitment to quality you get when you purchase Tyler Union products. It all starts with the melt stock. All raw materials that enter all of our foundries pass through a calibrated radiation detection system. Because the melting process does not rid iron of radiation, this system ensures that no harmful radiation will ever make its way into our products. Our quality castings are made from 100% recycled scrap iron. As such, Tyler Union domestic products meet green building and LEED requirements. The recycled scrap iron is melted in a blast furnace or cupola. Ingredients are charged in the cupola in specific amounts to ensure the iron complies with AWWA standards. Along with the scrap iron, a form of processed coal called coke, limestone, and silicon are charged into the cupola. The coke acts as a fuel source assisted by the 1,000-degree Fahrenheit blast air. The limestone acts as a flux to remove impurities from the iron, and these impurities leave the cupola as slag. Magnesium and silicon are carefully weighed and added to each ladle to complete the transformation from gray to ductile iron. Numerous samples are taken to verify the chemistry of the iron in each ladle that is poured at the foundry's molding units. These samples are transported to the iron testing lab by a pneumatic transport system. This ensures that the feedback from the lab to the cupola operator is accurate and immediate. The samples are ground and then placed in a spectrometer. The spectrometer burns the sample and provides an instantaneous report showing the percent of each element in the iron. The cupola receives the feedback from the lab and adjusts the raw materials as required to maintain the flow of high-quality iron out of the cupola. In addition to these samples, a test bar is poured every 3 hours during production. The test bar is machined to a specified length and diameter to meet AWWA testing specifications. The bar is then placed under tensile stress until it fails. Readings are automatically taken, which are used to determine the tensile strength, yield strength, and elongation properties of the iron. If the bar fails to meet any of the required properties, the product poured during that time period is quarantined and remelted as scrap. All test bar results are kept on file and can be accessed online for a specific product using the date code. These results are stored for 7 years and are used to ensure traceability of every required casting. With such a large stable of patterns, proper maintenance is a demanding task that requires specific quality procedures to be followed. Accurate calibration of the patterns is essential to maintaining dimensional accuracy required by AWWA standards. These tolerances ultimately determine the overall weight, thickness, lay length, and other dimensions of each and every fitting and casting. Before a fitting can be poured, a core must be made. The core forms the inside of the casting when the molten iron is poured around it. The core breaks down into smaller pieces from the heat of the iron after the iron solidifies around the core. Three methods are used to make cores at Union Foundry. The shell core process uses heat as a catalyst to activate resin in the sand, which solidifies the sand into the desired shape. The isocure core making process uses a gas as a catalyst to activate resin mixed with the sand. The air set process uses a resin mixed with sand that begins to solidify as soon as it is exposed to air. All three core making methods have their unique advantages. The core type used for each casting is dependent upon many variables, such as the weight of core needed, the size of the casting to be poured, and the number of cores needed. In all three cases, the cores are filed to remove fins or imperfections, and core wash, a mixture of graphite and water, is applied to critical areas of the core to reduce the occurrence of burnt-in sand to provide a smoother casting finish in the more critical areas. All three molding units at Union Foundry are green sand operations. The term green refers to the moisture in the sand. In order to maintain the sand's compactability, water and clay are added to the sand every time it cycles through the system. The molding unit at Union Foundry that produces the most tons per hour is the highly automated DISA molding line. The DISA makes most of our 10-inch diameter and smaller castings. The mold is vertical, and cores are set using a core mast that uses vacuum pressure to hold the cores in place until they are set inside the sand mold. The molds are filled with iron using a stopper rod, which moves up and allows iron to flow from a pressurized furnace into the mold. The furnace is continuously filled with iron from the cupola. After the fittings are poured, they pass through a drum to break the sand loose from the casting. The sand is then recycled, and the castings are passed through a shot blast machine. The shot blast machine cleans the castings and removes any remaining sand from the surface of the casting. The molding unit at Union Foundry that produces the second most tons per hour is the George Fisher DISA, or GFD molding line. This molding unit is also of the green sand process, but unlike the DISA, it makes horizontal molds, and the sand is placed in steel flasks. The GFD pours larger castings than the DISA, up to 24 inches, and the flasks help to hold the larger volume of iron in place and reduce the likelihood of iron running out of the mold when it is poured. Similarly to the DISA, the castings are poured and proceed to a punch-out area, and the sand and castings proceed into a large drum. Next, they are cleaned in one of three shot blast machines. The largest fittings are made on the B1. The B1 is also a green sand molding unit, and the sand is compacted inside large flasks using a jolt action. After the fittings are cast and cleaned, they travel to the grinding area. All flashing and imperfections are ground off the castings using pneumatic grinders. In the machining area, mechanical joint and flanged fittings are gang drilled for bolt holes. Flanged fittings are faced per AWWA standards, and all fittings are inspected to ensure bolt holes are drilled through. Next, the fittings are cement lined in accordance with AWWA C104. The cement is mixed using clean potable water and sand that meets NSF and Safe Drinking Water Act requirements. The viscosity of the cement is tested routinely to ensure the proper flowability and texture. This test is called a slump test. The cement is slung or sprayed into the waterway of the casting using specialty equipment. Any raised areas of cement are smoothed down by brushing, and any excess cement in the gasket area of the casting is removed. Several different coatings are applied to Tyler Union fittings. The most common coating is an asphaltic coating that is applied by dipping the casting into a dip tank. The viscosity of the dip is checked throughout the shift. and the temperature of the dip is regulated. After the fitting is dipped into the coating, it enters a curing tunnel which helps to drive the moisture out of this water-based coating. Being water-based, the coating has none of the volatile organic compounds or hazardous air pollutants that many other coatings have. Numerous other types of coatings are applied to our fittings as required to meet the ever-changing needs and specifications of the end users. Union Foundry operates using an Advanced Environmental Management System, EMS. This system uses record-keeping, inspections, training, and corrective actions to make sure that Union Foundry stays in continuous compliance with state and federal regulations. Multiple bag houses, giant filtration systems, capture the particles in the air coming from the foundry operation. No longer can visible emissions be seen coming from the foundry operation, and gone are the olden days of thick black plumes of smoke rising from the stacks. Filtration systems capture runoff water from the foundry before it leaves the property. Runoff water is tested during every rainfall event so that the foundry can verify that all water leaving the plant meets EPA requirements. All wastes are labeled and controlled in a designated area to ensure proper disposal. Sweeper and vacuum trucks run daily to capture any excess sand or dust and keep the foundry as clean as possible. Once the manufacturing processes have been completed, the fittings make their way to inventory. Tyler Union maintains a vast inventory to meet the ever-changing demands of our customers. Inventory is held not only at the point of manufacture in Anniston, Alabama, but also in distribution centers across the country. Currently, Tyler Union maintains inventory and ships out of Portland, Oregon, Chicago, Illinois, Elmira, New York, Corona, California, Tyler, Texas, Anniston, Alabama, and Orlando, Florida, giving us the ability to reach almost all major markets across the country in one day. Another example of our commitment to the highest level of customer service in the industry. Once the castings have been coated, they are placed into inventory in designated sell locations. Several months of the more common or stock items are kept in inventory to meet customer needs. When orders are placed, the fittings are picked from the yard. Often, a touch-up coat of paint is applied to the fittings before shipment. The fittings are then audited for accuracy, placed on pallets, and shrink-wrapped for shipment. Every effort is made to maintain a safe working environment for Union Foundry employees. Numerous training courses are conducted, both online and face-to-face. Employees are provided all necessary personal protective equipment for the jobs they perform. Guards with interlocks and other engineering controls are in place to further protect the employees. As a result, Union Foundry's injury rates are less than half of the national injury rates for foundries. To better meet the needs of our customers, we have call centers located in Corona, California, Tyler, Texas, and Anniston, Alabama. Our inside sales representatives are experienced and well-trained, exceeding even our toughest customers' expectations. We've learned a lot since 1911. Our commitment to quality has only grown stronger through the years. With the countless quality controls, verifications, test requirements, policies and procedures, and with the most knowledgeable and experienced staff, we continue to be the leader in providing quality waterworks castings at competitive prices. Tyler Union, meeting the needs of the waterworks industry and casting our name in quality since 1911.